Okay, here's part 2 of the 3.3 extension. We're now going to write linear inequalities. These are what we also call our constraints, okay? We're going to call them constraints because when we graph, we're going to have a feasible area or an area we're going to do shading, and that's where our constraints or linear inequalities are going to come into hand. Okay, so basically how we write all of these linear inequalities, they're going to come from the numbers from the problem it told us. So first, it says we can't make negative number of bowls, okay? Well, remember, bowls is represented as x. So we can't have negative amount of bowls, right? Well, then that means we have to have only numbers either 0 or positive. How can we write that as a linear inequality? Well, because bowls represents as x, that's what we're using as our variable, we're going to use x, and then we're going to set it greater than or equal to 0. This means that we can have either 0 bowls or any bowls that are in positive direction, okay? Now, then it says make at least 4 bowls. So if we go back to our problem, it did say that we want to make at least 4 bowls. So that's going to be part of our constraints. So once again, remember, bowls, we're representing that as x, so that's x. Now, when we think about at least, that means we want either 4 or more bowls. I'm going to write that down, 4 or more. Now, how can we write that 4 or more as an inequality? Well, that's going to be the greater than sign. Now, because we can also have 4, that means we also will have the equal sign to represent, that'll be part of it. So we'll have x is greater than or equal to 4. Now, it talks about plates, that we don't want anything negative. Now remember, plates we represented as y for our variables. So we can't have negative number of plates, but we can have either 0 or more. So if we think about 0 or more, well, that's going to be just like we did with the negative amount of bowls. Y is greater than or equal to 0. Okay, so we can have 0 plates, or we can have any positive amount. Okay, lastly, it says can use up to, but not more than 40 pounds of clay. So if we are thinking about this, up to, but we also have to think about, well, how much clay do we use for a bowl and how much clay do we use for a plate? Well, we got to go back to our little sentences for this. So a bowl uses 5 pounds while a plate uses 4 pounds of clay. So that means we'll have 5x plus 4y, and then we're going to use an inequality to represent we don't want more than 40 pounds of clay. Basically, the potter doesn't have more than 40 pounds of clay, okay? So that means we will have, let me go back to that again. So we have 5x and then 4y. There we go. So basically what that represents is that there's 5 pounds, so basically a bowl takes 5 pounds of clay and a plate takes 4 pounds of clay. Now, just say we want up to 40, but no more, okay? So basically we can think of we want all the way up to. So we think about that, that means we're going to have a less than, because we don't want more than 40, we want less than. But we can also have up to the 40 pounds, meaning 40 can be included, okay? Now you might be wondering, how did I know to use the clay stuff? Well, think about when we did systems of linear equations and we created our 2 equations. Well, clay, the pounds of clay, that all have something in common, the amount of clay used. So we all put that in one inequality. So we're going to use that same idea when we write this. Okay, so now it says the potter wants to maximize his profit, meaning to minimize the cost. Now, finding this, where we maximize the profit, minimize, this is what we call the objective function. So we already talked about the objective function in the first part of our video. That was when we wrote P equals, and it was 35x plus 30y, okay? So your objective function is always really to find either maximize the profit / minimize the cost. And it just kind of depends on what the question is asking you. Now, because we will have to use our linear inequalities to graph and find basically what was called the intersection. So the intersection of the graph of the above inequalities, remember we already got that, that's called the constraints, is the blank. Well, we call this the feasible region. Okay, so we will use the word feasible region. What this means is when we graph our constraints, we are going to do some shading. Basically, where the shading overlaps, that is going to be our feasible region. Now, I am going to show you a shortcut instead of always plugging in numbers to see if we shape left or right, because we are going to have what is called corner points, and that's our next thing here. We're going to have corner points, and these corner points are going to bound our feasible region. And so wherever those corner points bound our feasible region, that's the area we're going to shade. So that's going to make it a little bit easier so we don't have to do as much math to figure out where to shade. So it says the feasible region is bounded, as I said, so we'll have a maximum and a minimum, which occurs at the corner points. So these are vertices of the feasible region. So now let's go ahead, we're going to graph our linear inequalities and determine our feasible region and determine the corner points. Okay, now it says how many bowls and how many plates should the potter make in order to maximize the profit? Now we're going to get that into the third video. That's where we're going to do a lot of algebra to do it. But before we can do that, we have to identify our corner points and our feasible region in order to answer that question, okay? Now, on here, it will tell you what the scale on the X and Y axis go, just because on different problems, and I'll do this for the homework assignment as well, sometimes the numbers get large, sometimes they're small, so I will tell you what the scale is for the X and Y axis to make it easier. Now, what I'm going to do is rewrite all the inequalities that I had on part C. So I'm just rewriting our constraints. So we had X is greater than or equal to 0. We also had X is, I'm going to do these in different colors so we know. Then X is greater than or equal to 4. Then our next one I think was Y is greater than or equal to 0. And then our last one was, I think 5X plus 4Y is less than or equal to 40. Okay, so don't forget, when we are graphing inequalities, just like with equations, we do need to make sure it's in that mx plus b form. Now, this also could mean we might have vertical and horizontal lines, okay? Now, notice that on all of the inequalities, we do have the equal bar. That does mean that all of our lines are going to be solid, okay? So I'm first going to graph the x is greater than or equal to 0. Remember, when we just have x, that means this is going to be a vertical line. And so x is going to be right here when it's greater than or equal to 0. Okay? Okay, now let's go ahead and talk about when x is greater than or equal to 4. Once again, that is going to be a vertical line, and that's going to be at 4. So I count 1, 2, 3, 4. Remember, our scale goes by 1, and here we go. Okay. And I do make sure my line goes off the graph because I will have some intersection points here. Now, I'm going to do y is greater than or equal to 0. So here, that's going to be a horizontal line, and that's going to be on my x-axis. Okay. Now, the last one, 5x plus 4y, which is less than or equal to 40, I do need to solve for y in order to graph. So the first thing I need to do is subtract 5x from both sides. Remember, I have to get it into that mx plus b form. So now 4y is less than or equal to negative 5x plus 40. My next step is to get rid of the 4, so I divide every single term by it. So now y is less than or equal to negative 5/4 x, and then 40 divided by 4 gives me 10. Okay, so notice that 10 is my y-intercept. So I have to go off of there first. So I go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's my 10. I'm going to plot that point. Now I go down 5, then to the right 4. I go 1, 2, 3, 4, 5 over 1, 2, 3, 4. Let's do it again. 1, 2, 3, 4, 5 over 1, 2, 3, 4. I can't do anything more. Remember, all of our inequalities do have the equal sign, so all of the lines are solid. So I'm going to go ahead and connect it. There we go, okay? Now, let's go and talk about the feasible region. So this is where basically when we have two or more lines, when they intersect, they're going to create corner points, okay? I'm going to write that. So our corner points or it could be more. Usually it's going to be probably just two lines, but it could be more, where two or more lines intersect. Okay? So here, I see where my green and my black line, they intersect. That's going to be a corner point. Now I also see where the green and the blue line, that's going to be a corner point. And then lastly, I do see where the blue and the black line, they intersect. That's going to be a corner point. Now you might also be wondering, well, we also have the red and black line, that's a corner point, and the blue and red. However, we want to make sure that we are bounded by most of our lines here. And really it's going to be our triangle there. Now here's another way we can tell. It's with the shading. So if x is greater than or equal to 0, that means we would shade right. So I'm going to go ahead and shade right a little bit. I mean, not to do too much. Okay, here's my shading, right? Then with the x is greater than or equal to 4, I shade to the right as well. Ooh, I'm already seeing some spot where the colors are mixing. Now y is greater than 0, that means we're going to shade above the line. Okay. So right now, do you guys maybe see where all three colors are intersecting? Oh, I kind of do. I see it like right here. I'm going to take my black. Okay. So I do see where the red, the blue, and the green intersect, and really that's where our black will intersect as well. So that's where all of our shading, in this case, quadruple shading, I guess, this is where this is called our feasible region. And so the corner points bound this feasible region. So this is going to allow us how we can tell how to maximize our profit and minimize the cost, okay? Okay, so in the next video, we're going to be talking about using the corner points to determine how to maximize our profit and minimize our cost.